This is what we're making today. It's a barn door winch that I use to open my barn for me in the morning and then close it at night. It has a photo cell outside, so it does it at dusk and dawn. We make this winch. We converted a garage door opener and then mounted it all together, did the cabling. All right, let's get started. All right, the heart of the winch part of this is this piece of pipe. It's 3 inches by 13 inches. I need 5 different spools for my cabling. Actually, I'm probably only going to use at this time 3 of them, but I eventually could wind up having to have 5, so I'm preparing for that. Okay, and so then I poured, this is an end cap that's going to get pressed into this end right here. And another end cap for this end right here. And then these are the dividers that will divide the spools up. Now I cast all of these in aluminum. I made a 3D pattern and then cast these in aluminum. And I didn't film casting these. I've filmed a lot of castings recently, so I just did this one the other day and didn't film it. But these are the castings right out of the molds, and I've got to cut these screws off. And then the first thing I'm going to do is start getting these trimmed up so that it'll fit in the ends of the pipe, and then get these trimmed up so that they'll fit onto the barrel. Got it mounted in the lathe, and I'm going to get this diameter down to 3.5. Just knocked that last little bit off I couldn't get with the lathe. There's the first one I did. Let's see how this one does. Yeah, that'll slip right on there. I'm going to epoxy these in place, so I just want kind of a slip fit on them. I've got these discs laid out where they go, and so the next thing I'm going to do is mix up some epoxy and get them all glued in place. There's not going to be really any load, you know, side to side on them much, so I think the epoxy is going to hold fine. This is just some Harbor Freight cheap epoxy. Okay, so I got the end bells trimmed up on the lathe, and I forgot to record it, so I don't have that, but it's got a 1/2 inch hole in the center, and I just cleaned up this face and this face right here. This one I had to kind of step it because it had some sink right there. But I'm getting them pressed on. I've got the bottom one pressed on already, and now I'm just pressing on the top one. These hubs were pressed in, so I don't think they're going anywhere, but I still want to put a lock screw in there. And so I'm going to put in these 1/4-20 bolts. Alright, I got some aluminum tapping fluid, because I'm really not tapping the steel. Alright, I think that'll work great. I'll put some Loctite on there before I put it in permanent. I'm getting ready to drill a hole to pin the shaft to the drum. I'm going to Loctite it in there, but I also want a physical pin to hold it in place. This is a number 21 drill. Your pin should be no more than 1/3 the diameter of your shaft, and this is a little bit under that. So. Alright, now I've got the shaft in place and I'm just going to drill through it. I did check and the bit's going right through the center of that hole. Now I'm cutting holes to be able to drop the cable into so it'll hold it, kind of retain it while the drum turns. And I'm just starting with a 1/4 inch drill bit. Alright, now that I've got that 1/4 inch hole drilled, that's what the stop ferrule is going to drop through, and then I need to cut a little slot so that you can drag it forward and it'll catch that wire. So I'm just going to cut a slot that's about 300 thousandths long. This is a sprocket off an old bicycle, and this is going to be our drive sprocket for our winch spool. And so I'm just turning a piece of scrap down here to make a little mount for it to mount onto the axle so that I can braze it on there. So now I've got to drill this out to 1/2 inch. This is a number 7 drill bit. It's the drill size for a 1/4 20 tap. That's a 1/4 20 tap. I should have done this step before I tapped the hole. And there's our tapped part. Ran the reamer back down through the inside just to clean off any burrs that there might be there. Okay, I'm going to MIG weld this collar into our sprocket. And I've just got a large bolt down through there just to kind of keep it pulled down and straight. I've gotten quite a bit of work done on this, and I didn't show making all this stuff because I don't think anybody really is ever going to do this, but even if you do, the electronics it'd be really boring to show how all this was done. And I did this schematic, which you can't read because I did it in Smart Draw. It was this online program, and it doesn't tell you that when you, it says you get it free for like a month or something like that. It doesn't tell you during the free period that it's going to put these watermarks all over everything that you do. But I'll post this schematic on the website, on my blog, just so I mean, you can read it. It's just really annoying with all that. This is not something that I do very often, so I tried to find a program so I could put it out there for you. And I have no interest in doing it again. But this is how it works, so I'll post that out there for you. But this is just a photo cell that'll turn it off and on. This will be mounted outside. This will open it when the sun comes up and close it when the sun goes down. That's how it will work in normal operation. So this is how you'll control it when you don't want it on automatic. If you put it up there, the photo cell will activate it, and when you're needing to move it independent of the automatic, you'll use this. So it's in closed mode right now. And there we are in open. You can see the drums turning this way. That'll pull the cables in. And then when you want to close it, of course, you just go the other way. We're using an old Craftsman garage door opener, and I made these little switches on here. I 3D printed this part and put some little switches in here. They're limit switches, so that this determines how far it opens and closes, and this came on the garage door opener. And then there's just relays that these activate these relays to control the motor. If I had had bigger switches, I could have had these limited without these relays, but I didn't. And anyway, so this is how it's wired up. Let me show you over here how the drive works. So this sprocket came on the garage door opener, and this chain actually came on the garage door opener. This came off of a bicycle, and we made this part right here as part of the drum. This is how that operates. Let me just... There you go. Alright, so just before I got it all closed up, I just wanted to show you this much of it. Okay, so here's the barn door winch installed. I still got to make a cover for here, but this adjusts how far open and closed it is, so I just, I'm going to leave that open for a little bit till I finally get it adjusted just how I want it. Here's the switches that we mounted. Manual, it's closed now. You can flip it to open. And it opens all the doors, and then you can flip it to close. And it closes all the doors. Flip it to automatic. Right now it would open them because the sun's up, and then at night when the photo cell gets deactivated, it'll close. For my goat stall, it runs off of here. This is my pigeon door, and this is my chicken door right here. And the cables run up, and there's the pulleys that we made, and they start running the cables. That one goes over to the chickens, and these two run out to the pigeons and the goats. The cables come out of the wall there, and then I connect to some polyester braided rope. And what that allows me to do is use smaller pulleys like that one right there, that the rope can take a much tighter radius than that wire rope can, and so these pulleys are much cheaper. And then I had to go through this wall, so I made a little copper slide that'll protect it from abrasion, the rope. Alright, well I hope that was interesting to you. Thank you for watching.